Hi friends, this is lesson 4, and most of it is a review of algebra. So your teacher probably showed you Slope Dude back in the middle school and algebra, and we're going to watch it again because it's cheesy, but everyone always remembers it.
Meet Slope Dude. He loves to ski. We are going to follow him, and he'll teach us some important aspects of slope. This is the course he's skiing today. What he says will teach us about slope. Always remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside. Puff, puff, positive, puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain, but now he can look forward to the downhill. On the way down the mountain, he says, nice, negative, nice, negative, nice, negative. And now, after the downhill, he's in for the hardest part of the ski route, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. As he finishes the flat part, he doesn't see well ahead, and all of a sudden he comes to the edge of a cliff. It's straight down. He finds a slope that is straight down, and so frightened is he that he says the worst curse word possible in math and in algebra. Undefined. This has been the adventure of Slope Dude. Remember always what he said during his ski trip. Up the hill or up the slope, he said, puff, puff, positive. On his downhill run, he said, nice, negative. On the long, flat part of the course, he said, this is zero fun. And finally, when he went over the vertical cliff and straight down, he yelled the worst curse word of math and algebra, undefined. The uphill is slowly positive, uphill downhill.
Super cringy, I know, but I promise on quiz day you won't forget. All right. So, we are on page 18 if you've printed these out. Everyone else, just write down each problem in your notebook. 18. Sorry, I should have had this ready. Oh my Lord. Whew. Okay, so there is Slope Dude. All right, so classifying slope, that's called a positive slope. Ew. Going uphill, and that is your negative slope, because it's coming downhill. That's why he's saying always look from left to right. Are you going up the hill or down the hill from left to right? Left to right. This is zero fun, and you can't go left to right on a vertical line. That's why it's undefined. So those will be on your quiz. Oh, I guess I should have wrote that right there. Those are some easy questions to get right. Okay, so you learned this in 8th grade and then again in 9th grade. So finding the slope given the graph, finding the slope using ordered pairs. And slope just means how steep is that line. The steeper the line, the greater the slope. So don't use a formula, even though you have two ordered pairs right here. When you just have a graph, you want to use the rise-run method. And it means when from this point up to this point, how much did you rise and how much did you run? What's the change vertically and what's the change horizontally? So just count. If you had to go straight up and over, how many did you go? 1, 2, 3, 4. And then you would have to jump 1, 2, 3, 4, 5 to the right. So if you move from dot up 4, right 5, that's how steep the line is. 4 over 5. And it's always the rise over the run. And it's positive because Slope Dude would be saying puff, puff, positive. All right, so these are the ordered pairs that match with this. A is left 2 and no, it's not. These are random numbers. Okay. So you could graph these two dots and count the rise run, but it's almost faster in this sense to use the formula. Where do I write the formula? Right here. Y minus y and x minus x. You always see the little 2's and 1's, because technically there's an x1 and a y1 and an x2 and a y2, and it's not going to matter as long as you go the same way. If you do this minus this, and this minus this, or this minus this, and this minus this, just go the same way, and you won't ever get these wrong. All right, so we know the y's are the up and down. The y's are the second number. So if somebody does 5 minus -1, if somebody else does 1 minus -1 minus 5, they're going to get the same thing in the final answer. So it's just like the distance formula. Back number with the back number, and you're subtracting. And then the front number and the front number. Again, but if I started with the 5, I have to start with the -2. That's the only rule. -5 minus +6. So in your calculator, that's a minus sign, that's a negative sign. And then you just simplify it. 5 minus -1 means 5 plus 1, which is 6. -2 minus 6 is -8. Now the rule is you're not supposed to leave a negative in the bottom of a fraction, so you just move it to the side of the fraction. And 6/8 is the slope, but it's not reduced yet. Cut that in half. Cut that in half. Should always reduce your slopes if they're a fraction. So that means it was going nice negative, down 3, right 4. This means up 4, right 5, because up is positive and right is positive. There's only one negative sign on here, so that would mean down 3 and right 4. Okay, that should be review from middle school and Algebra 1. Let's skip to that weird one. Skip to number 3, because number 2 is the same thing. It just ends up being a negative slope. We'll do 3 and 7 and see what's going on there. Okay. So if you have to put the rise on top, that means you're counting up and down first. From this dot to this dot is 1, 2, 3, 4, 5, 6. Either up or down 6, depending on which dot you started on. You don't have to run it all. You don't have to go left or right to land on that dot. So if you type that in your calculator, don't just guess, like, is this going to be 0? Is this going to be undefined? The answer is definitely not 6. Because 6/0 is the same as 6 divided by 0. And your calculator will say undefined. But also, slope dude says undefined, you know? So that's how you remember it. You can almost just not even do any counting at all. There's the line right there. What does slope dude say? This is 0 fun. So you know the answer to that is 0 and not undefined. We could count, set up the fraction, but slope dude is the quick way to get the right answer on all verticals and all horizontals. They're not slanted, so they don't have a slope. Well, this has a slope, it's just nothing. This doesn't have a slope, because you would die when you fell off that cliff. All right, so here's a perfect example. If you're using the formula for this one, picture 9 -4 would be over here, and 9, 2 would be up here. So you kind of know the answer right away, but look at it mathematically. Y minus y, back minus back, -4 minus 2. Ew, there's these little dots all over. X minus x, that's the front and the front. 9 minus 9. So it doesn't matter what's on top. Anything divided by 0 is undefined. It's not 0, it's not -6, it's undefined. If you had 0 divided by 6, that's when you get 0. But that didn't happen on this one. All right, so that's my review. Now let's go to the new stuff. You're using what you already learned to do a problem like skip to page 20. The vocab is review from middle school, but the math might be new. Page 20. All right, we'll fill in this. Because So your teacher should have taught you that parallel lines mean lines that have the same slope. Parallel lines look like this. So if a slope means how steep is it, that line is the exact same steepness as that line. So parallel lines have the same slope. Perpendicular lines, look like this, with this perfect, doesn't look perfect, a perfect 90-degree angle right there. There's something very special about their slopes. Negative, reciprocal slopes. So that might be a brand new word to you, a negative reciprocal. So we're going to learn about what that means and do some examples. So just because it's negative doesn't mean it's going to have a negative sign. It just means the opposite sign. So you're always going to change the sign, because clearly slope due to skiing downhill that way, but uphill that way. So perpendicular lines are going to have a positive and a negative for their slopes. And reciprocal just means flip the fraction upside down. That's from middle school too. The reciprocal of 7/3 is 3/7. So if the perpendicular lines have negative reciprocal slopes, that means you change the sign and flip it upside down. We're going to change the sign and flip it upside down. Oh, opposite sign, that should say. So change the sign of 3/4, it's going to be negative. And then upside down 3/4 is 4/3. That's what that means. All right, so same thing. 2 is positive right here. It's going to be negative. 2 is always over an imaginary 1. So the reciprocal for 2 is 1/2. All right, this one says -7/8. So if that's a negative, your new slope is going to be positive, and flip it upside down. The common error is people will just flip it and forget to change the sign, or just change the sign, but you have to do both. So this is a +1. We know we're going to need a negative, but a 1 upside down, 1/1 is still 1/1. So that's a weird scenario where it doesn't really change. And then a 0/1 would become 1/0, and that's an undefined slope. Okay. All right, last problem. We're going to use this idea and use this new rule to determine if these lines are parallel, perpendicular, or neither. Because sometimes if you just draw it, it won't look exactly perfect, and you won't be able to tell if it's truly parallel or not. So we're going to do the slope formula twice. Clear mouse. Ugh. Okay. Use slope to determine if lines AB and CD are parallel, perpendicular, or neither. So let's see what the slope of AB is. Back minus back, 6 minus 3. Switch. Front minus front, 2 minus -2. Started with the 6, started with the 2. So the slope of this one is 6 minus 3 is 3. 2 minus -2 is 4. So the slope of AB is +3/4. Circle that. And now we're going to find CD, back minus back, 3 minus 0. Front minus front, 3 minus -1. 3 minus 0 is 3. 3 minus -1 is 4. And now you don't have to guess. Because parallel and perpendicular neither, that's only 33% chance that you're going to guess right. So test it out and prove it. 3/4 and 3/4. So you know, oh, do they want us to do this? The slope is 3/4. The slope is 3/4. We are sure that they are parallel because they have the same slope. I think that's all I need to do. Because even if you have, basically it has to work out so that you have negative reciprocals for your slopes to choose perpendicular. Guess we should do one that works out to be a neither. I'm assuming this number 3 works out to be a neither. Let's test it out. All right. 6 minus 8 is negative 2. 2 minus negative 1 is 3. Okay. So we're looking for positive 3/2, and then we get to pick perpendicular. 3 minus 2. It's not looking good. 3 minus negative 1. All right, so this worked out to be positive 1 over positive 4. So they're not the same. Wait, negative 2/3, positive 1/4. They're definitely not the same slope, and they're definitely not negative reciprocals of each other. So that's when you would pick neither. All right. Good luck, everyone.